Alright, today we're going to talk about modeling equations. So go ahead on a piece of paper, start completing these notes. Title them Modeling Equations Notes. Some prior knowledge we're going to need is, well, our first thing is opposite numbers. So we've talked about opposite numbers, for example, being -3 and 3. These are opposite numbers because they cancel each other out. So if I take -3 and I add a +3 to it, I know that I'm going to get 0. If I start with a +8 and I add -8 to it, I'm going to get 0. If I take -1 and I add its opposite of +1, I get 0. So we see that every single time we're adding an opposite number to its opposite, we get 0. In this case, we're going to call this canceling it out. You'll hear me say that throughout the video. We're going to cancel a number out by adding its opposite number. Second piece of prior knowledge we're going to need is what we talked about today in class, which is equations. We know that an equation has a variable. It could be x, it could be t, it could be p. We also know that this is going to have an equal sign. And this equal sign we're going to concentrate on right now and focusing on what an equal sign really does mean. So if I take something like a number +3 is 8. And we talked about in class how to write that. But what does this really mean? That means that this side, the left-hand side of the equal sign, is equal to this side of the equal sign. So anything that we may do over here to keep it balanced, we have to do the same thing over here. If we don't, and let's say we just do something to the left-hand side, and we don't do it to the right-hand side, we now will see that this will become unbalanced. Okay, it will look something like this. We need to keep this equation leveled, so what we do to the left, we do to the right, and vice versa. Some important symbols we're going to need as we model our equations today are for three things, whatever the variable is. So let's first start with that. So again, that could be x, it could be t, it could be p, it could be o. Whatever our unknown is in the equation is just going to be a long rectangle. And that's going to stand for our variable. So again, that could stand for x, t, or whatever our variable is. Okay. Our positive one, if I have positive numbers in my equation, and this will make more sense as we actually go to model these, will be a blue square filled in. And that's not completely perfect, but you know what I mean. A -1 is going to be a red square filled in. So again, the blue stands for a positive one, and my red is going to stand for a -1. Alright, the first example that we're going to model in this equation is x plus 3 is equal to 5. So we could, and we all know the answer to this, but can we model what this means and really understand why it is the answer? So our first step is to actually model this. So using our symbols that we just talked about, we're going to start with our unknown. We have x, so I'm going to model my x by just a long rectangle. From here I have a +3. So everyone says, well, that's +3. A plus sign is the same thing as a positive. So we're now going to look at this as a +3. So I'm going to write out 1, 2, 3 squares for a positive. And I could color these in, but you know that they are blue. So I have 3 positives. My equation, I'm just going to draw a line so I know that it's separating. So that's one side. On the opposite side, I have another positive. So again, even though I don't see a plus or a negative sign, I know that if I just see a number, it's going to be a positive. So I'm going to write out 1, 2, 3, 4, 5. So I now have 5 blue squares. Next question I have to ask myself is, okay, I want to solve for x. I want to get x alone. So on the left-hand side of the equation, I have to figure out how can I get rid of these 3 positive squares. Well, using our opposites, I know what can cancel out 3 positives. Well, 3 negatives will cancel these out. So to that side, I'm going to add 3 negatives. From here, I know, okay, that's gone, because a positive cancels out a negative, positive cancels out a negative, and here. So I got what I wanted. I want x to be alone. However, what I do to one side of the equation, I must do to the other. On this side, remember, I added 3 negatives. So to keep this in balance, I need to add 3 negatives to this side. And that's what it should look like here. Let's go ahead and let's cancel out, because I know a positive and a negative cancel. There's one. A positive and a negative cancel, and a positive and a negative cancel. Can I cancel any more? No, because I don't have any more negatives, and a positive don't cancel. So from here, let's kind of bring down what I have. I'm going to extend my equal sign. My next step is just bringing down what I have left. I have my x on the left, and if I look on the right-hand side, all I'm left with now is 2 positives. So as I get down to this step, I read this as, if I can like translate this back into math talk, I have x equals, I have 2 positives, so I have 2. My final solution is x equals 2. The last example we're going to do is x minus 2 is equal to negative 3. So let's go ahead and start modeling. So to model this, we're going to take our variable. So we're going to start with our x, our long rectangle. I see this now as a negative 2, so I'm going to need my red squares, 1, 2 red squares. I'm going to extend my equal sign just as a line, and now I'm looking at this as, okay, now I have a negative 3. So I'm going to do 1, 2, 3 negatives. Okay, so that is our first step. Model the initial problem. From here I have to ask myself, I want x to be alone. Currently on the left-hand side it is not alone. I have 2 negatives. So I have to ask myself, what can I do to get rid of those 2 negatives? Well, I know 2 positives will cancel that out. So I'm going to add 2 positives to the left-hand side. I know that I can show this, and that will cancel. However, right now the equation is unbalanced because I added 2 negatives to the left and not the right. I'm sorry, I added 2 positives to the left and not the right. So I'm going to take my blue and I'm going to add 2 positives to the right to keep it in balance. From here, let's see what I can cancel out. 1 and 1, and that is all I can do on the right-hand side. Let's bring down what I have left, and I have a x on the left. On the right-hand side, I am left with a negative 1. So if I translate that into math terms, I have x equals negative 1 as the solution to my equation.